3. Good afternoon, or maybe it is a good morning, or even a good evening, depend where you are on the globe. My name is Kobi Zauschnitzer, and I'm the VP for Business Development and Marketing at SCD. My passion is identifying operational needs, exploring capabilities gaps, and bridge them with technology and products which will enable customers and end users success in a cost-effective way. I'm doing so in the last 25 years, from engineering position to leading product development, leading business lines, and leading global business development, company growth, and strategy growth. I'm welcome you all to our first webinar, live here on our webinar channel, as well as on SCD LinkedIn page. Welcome. We are opening a series of webinars which will discuss technology, operational needs, and effective ways in the IR domain to bridge the gaps. Today, we will talk about the Sparrow, SCD's smallest mid-wave IR detector and video core, the world-leading solution for low SWaP-C, superb thermal imaging. The first thing which crossed our mind when we prepared this webinar was the picture that you see here in the slide. How the Statue of Liberty related to the Sparrow. Remember this picture? We will come back to it later on in this webinar. One thing before we start, the chat is open. If you have any questions, don't hesitate. Put them into the chat and we will come back to you. If not in the end of the webinar, I'm promising you we'll do it by mail. And now, before we start to talk about the Sparrow, I want to provide you few things about SCD and to give you a short introduction to SCD, who we are and what we are passionate about. For more than 4 decades, SCD enabling night imaging in different wavelengths, different sensing material, and to a wide range of application. We are providing the core of thermal imaging from semiconductor devices to IR video core. 4 decades of technology development, hundreds of thousands of IR detector operational fielded. As a global infrared technology leader in the infrared sensor market, we are developing, manufacturing, and selling infrared detectors worldwide, providing solutions across the IR spectrum, for near infrared to shortwave infrared, midwave infrared, and longwave infrared, cool detector, uncooled detector, different kind of flavors, different kind of formats for different kind of detectors. We at SCD, we are a full vertical integrated company, both in R&D and in manufacturing. Our infrared fab is one of the largest IR fab worldwide, and the economy of scale in our production enable us providing customers added value both in performances and cost effectiveness. Our capability starts from the material growth based on our MBE machines, where we grow unique sensing material such as superlattice, XBN, and others, continuing with advanced semiconductor fabrication process, flip chip bonding, FPA packaging to detector assembly. Our facilities include the final testing and robust verification processes meeting the most demand defense and commercial standards. We are continuously invest significantly year over year in R&D and capital to maintain our global leadership in the front of the IR technology. Our people is the core of our heritage and the core of our global success. Our products are integrated into the most demand applications, such as missile seeker, man-portable devices, such as handheld or tripod-mounted, armor fighting vehicles, in weapon sight and situational awareness, and up to the most advanced airborne targeting and reconnaissance payloads. Our detectors are the core of missile warning systems and the demanding persistent surveillance application. Listening to our customers and understanding the operational needs, combining with global technology leadership, enabling us providing innovative and advanced IR imaging solution. So, that was a short introduction to SCD, and here now I'm happy to join this webinar a colleague and a friend, Dr. Tuvi Markovic, who is the VP for Land and Naval Business Unit at SCD. Tuvi received his PhD in physics from the Technion, joined SCD 20 years ago, and started as a physicist in the R&D division. Tuvi led product development, program, and customer management, leading SCD cool technology and product line. Currently, Tuvi is the VP for Land and Naval Business Unit, but actually, in 2 weeks from now, just 2 weeks from now, starting from March 15, Tuvi will become the VP of R&D. Welcome, Tuvi, and great success in your new role.
Thank you, Kobe. Hello, people over there. I'm really happy to join the Sparrow webinar, and also excited to start my new role in SCD. But let's talk about the Sparrow. Let's go and describe what we have in mind.
Let's talk about the Sparrow. Before we talk about the Sparrow, I want to talk about the technology gap. 4 years ago, or even before that, the customer came to us and told us that they have an operational gap. The operational gap was very clear. For the dismounted infantries and for the main portable application, they need to change their DRI ranges. They need to change from operate at 1 kilometer or up to 1 kilometer to work with the DRI ranges from, I would say, from 1 to 3 kilometers. This is a huge change. They need to work in a standoff operation. They need to increase the lethality of the forces, and using the regular uncooled systems was not a solution. Apparently, the uncooled are a great solution when you are walking in a few hundreds of meters, but once you need to go above 1 kilometer, and especially if you go to 2 and 3 kilometers, the uncooled system become very big, heavy. Yeah. They are even not affordable, and they didn't have the capability to leverage thermal imaging in the field in this new advanced requirement. Now, I'm having with me here, this is the Pelican D. The Pelican D is a superb MWIR detector. This is a VGA 15 micron pitch. Actually, we are manufacturing thousands of this detector year over year in the last 10 years. The performances are excellent. The customers ask us, can we provide them a Pelican D performances, imaging, detection, but cutting the size, cutting the weight, cutting the power consumption, and not less important, cutting the price. The price is very important. Can we do that?
So looking at the product, well, you can cut 10, 20%. Everybody can do that, but actually they wanted something much more. So they wanted something which is at least half the size, half the power, etc. So let's look at the product. If you look at the standard detector, you see that it is composed of two major components. One is the DUR at this end, and at the bottom we have the cooler. Now the cooler is a significant part of the product because of its weight, because of its power, the power that is needed to cool it, and of course the size. So if you want to take a cooled detector and squeeze the size significantly, you need to solve this challenge of the cooler. Now people along the years try to have higher efficiency of the coolers and decrease their sizes. So it could be done, but to some extent, 10%, 20%, but we are looking for factors, factor of 2, factor of 3. So just working with the efficiency of the cooler is not enough. So we had a different approach. The different approach is the operating temperature of the focal plane array. Normally it is 80 Kelvin, but imagine a situation where it is much higher, high operating temperature focal plane array. If you can achieve that, then everything will become much smaller. Not only the cooler, the whole structure will be completely different. And we took that approach in the technology of the sensing material and introduced about 10 years ago the XBN sensing material. It's a patent of SCD, And we have produced new type of products operating at elevated temperature at 150 Kelvin. And these are new products are actually an enabler for the new type of product that we can do around them.
So Tuvi, this is actually a breakthrough. Developing this kind of a sensing material and changing from 80 Kelvin to 150 Kelvin, this is a breakthrough. Any drawback with this technology?
So today, as of today, we can get the same performance with the standard indium antimonide and the XBN material. We can maintain the same quantum efficiency, high sensitivity, uniformity of the image, bad pixels. There is one thing that actually was a concern at the beginning, the early days of the technology, and this was the cutoff of the sensor. So the XBN sensors have a 4.2 cutoff. And some of our customers were a bit worried about that, whether they will get the same DRI performance or not.
When you say 4.2, just to emphasize, the full midwave is 3 to 5. So the XBN is 3 to 4.2.
Exactly. And people have done some calculation that show that for every ground application, you get the same performance. Even for long-range surveillance, it's even better. So some came back to us and told us, okay, even with a standard solution, I want a 4.2 cutoff on the filter, put a cold filter inside the product to block completely what is called the red band. And once it was introduced, the XBN was introduced in the market, and people try that and work with that, and they see that they get great performance. So now it is all over with land application, airborne application, all sort and kind of applications in the market.
You know, we know that every time that there is a breakthrough in technology and a new technology developed, there are also some issue with that. How confident do you feel with the XBN technology? What is the maturity of the technology?
We feel very confident since we have produced that for the last 8 years in serial production. Different formats, started with the 15 micron pitch family of detectors like Hercules, which is the HD, Pelican D, which is the VGA. Once we went into the 10 micron family of products, it is coexisting side by side with indium antimonide. We have in the production line our own MBE machines that produce this type of materials, controlling layers of atom in order to grow that. So we are in full control, have legacy of several years, thousands of detectors in the field with this technology. So we are very confident with that.
So XBN technology is very important and probably one of the core elements which we need in order to make a change in a cool detector. But when the customer talk to us, it is not enough, because they talking about also the customer experience of working with cool detectors. They want to reduce the time to market. They want to reduce the resource that they invest in this kind of integration. What can we do in order to do that?
So another element that you should consider is a plug-and-play solution. So once you have a detector, a new one, then you have to learn the detector, to understand it, to know how to operate it. It has its own video output. You need to correct the image and do all the work around it in order to have the first system working and demonstrating your system. Now, think about when they came to us, the customer, they asked for something which will fasten their way of work, and we came up with the idea that anyhow we have the electronics of the detector, so we can put some more abilities inside the electronics of the detectors, like image processing. And once you have this layer of software inside the electronics, the task becomes more trivial, because you just power up the detector and get a corrected image or a fully processed image, and immediately you can start to demo your system. So another element of time to market is and cost. It's the development cost, is the trivial interfaces that you can put in the product.
So we talked about core technology like the sensing material. We talked about interfaces and customer experience, which is essential for this kind of solution. But, cost in the end is a key when you are selecting your product, and cost of MWIR detectors are high. Did we, or what is your approach in order to reduce the cost of the product?
So the cost of the Sparrow was an issue because we aim at a system which are mass production, like every soldier or every many payloads on drones and this type of application. So cost is a strong parameter in the product. And analyzing that and how do we do things different, there are two elements to do that. One is very straightforward. Everybody in the industry know that it is coming from the design. The design itself should be a design to cost. The way you design your product for easy assembly, easy manufacturing, easy testing, the way you design your production line along with a product, all of that is on the design. But this is one part. The other part that we change in the concept of the Sparrow is related to something called the economy of scale. So if you can do the same product over and over again, exactly the same product, then you get very high efficiency in the production line. And this is one of the concepts behind the Sparrow. So whenever you have a cool detector, people normally ask about customization. I want a different F number, different filter, different cooler, which is okay. But if you're looking to do something very cost effective, you need to go into standardization. And one of the concepts of the Sparrow is making a standard product that everybody will use the same product, and then the cost of production will be reduced.
So we talked about cost, we talked about interfaces, we talked about technology.
Yeah.
Combining all of this together, what is the Sparrow?
So taking all of these together, we came from the ideas to the first concept 4 years ago, and actually it looked like this element that I'm holding here in my hands. And this was the first element, and this vision came through, and here I'm holding a real Sparrow. Okay, so you can see the product itself. And we would like to introduce you the building block of the Sparrow and explain how it works.
Before the building block, just to say, did we achieve the target? Let's look on the Pelican D and the Sparrow.
So if we want to compare between the Pelican D and the Sparrow, both are VGA detectors, but look at the size difference is much less than half. And if you look at the power consumption that we achieve is less than 4 watts, which is less than a half. Cooldown time is very quick, so all the swap parameters and the cost structure are achieved with this product.
When I'm looking at this, the first thing which crossed our mind is actually for today's new demand and new applications. And you mentioned the drones. We know that the autonomous platform is becoming more and more effective in the fields. And we know that handheld requirement for man-portable application, for infantry are crucial. This is something like a GoPro approach. This is something like a GoPro approach, or I would say an infrared pro solution for today's requirements. So let's talk about the component and how this enabling our customers to go to the new requirements in the field.
So maybe let's start with the heart of the Sparrow, which is the focal plane array inside.
So I brought with me the FPA, the unique XBN FPA. I hope that all you can see here in my hand, this is the FPA.
Yeah, so you can see a tiny FPA on the fingertip of Kobe's hand. And this is the actual FPA of the Sparrow. It is a 10 micron pitch XBN technology, VGA format, and it is extremely small. And now if you compare it to its legacy, the Pelican D, then the size is half in each dimension. So the area is quarter from in respect to the Pelican D, and you can see it on the image beside me. And this is very important in terms of the cost of production, because fabs work on focal plane arrays that are in wafers. And the cost structure is strongly related to the number of FPA that you can put on a wafer. So if you can double the number of focal plane arrays in your wafer, then it's significant in terms of the cost.
Where this FPA hides in this product?
So let's go back to the detector itself. So actually you cannot see it. It resides inside this metal DUR inside. This is the level of the FPA roughly here. What you can see here is the front window. So the front window is where the light comes in and received by the focal plane array. And once the focal plane array is very small, also the DUR is very small. You see, it's very narrow and accommodating the size of the focal plane array. But not only the DUR, also the cold shield that sits above this focal plane array becomes very small, proportionally very small. So it's only 12 millimeters in height, and the total length is now very short. Now, once the FPA is short or small, and the cold shield and all the optics of the detector, it impacts also the optics of the system. So the whole optical arrangement of the system becomes very compact.
Yeah,
so not only the detector is low size, but also the system becomes
I think now when you're saying this, I think this is a major issue, because we're talking about the detector, but in the end, it's a sweet spot of a system. And we are talking of a small FPA, 10 micron pitch, working with F number 3.6, which enable you to go to a very compact and a very low swap optics as well,
while achieving ranges of 1 to 10 kilometers.
Exactly. So if to compare, we want to achieve the same, or I don't even want to say the same, maybe I need to say we want to achieve distance between 1 to 2 kilometers with uncooled, you need to go to a very large optics, a very costly optics. The detector will stay low cost or very low cost, but the optics becoming a big change in the system. You get a very big system, weight a lot, the aperture is big, no soldier can take it with him, you cannot put it on a drone, you cannot put it on a weapon, you cannot do nothing with it. So this is the big change.
Right, and this is part of the idea of the Sparrow, but there are other advantages that were plugged or designed into the Sparrow. One of them is this guy beside the DUR, which is the cooler. So this is a Ryker cooler designed specifically for the Sparrow to leverage from the high operating temperature and the low size focal plane array. So we wanted to maximize the performance of the cooler, the size of the cooler, to be achieved with this high operating temperature focal plane array.
Tuvi, I see that we all can see here that this is a linear cooler. Why did you choose a linear cooler?
That's a good question, because the linear technology has some advantages in comparison to the rotary one, and there are several advantages in this product. First, this linear motor is very quiet, and this is very important for applications where you are undercover, or nobody should hear the camera working. So this is one advantage of this linear motor.
Very important.
Very quiet. Another advantage is related to a totally different type of application, which is the airborne payloads. Now imagine a small payload like 7-inch, 5-inch. You need to control the line of sight with these small payloads. Any small vibration coming from this product can affect the stabilization of the line of sight. So this is a dual piston solution, low vibrations. So this is supporting the payload peoples again. And the third thing that is the advantage of this solution actually is a combination of linear technology and high operating temperature. When you combine these two technologies together, you get a very long lifetime of the cooler and of the product.
When you say long lifetime?
In this case, over 30,000 operating hours.
Wow, this is significant change from the standard mid-wave IR detector that we know, which is around 8,000 to 10,000.
Right.
So actually, when we say that we are addressing the cost and the price, it's not only addressing the cost of the price of this Sparrow product, we are also addressing the life cycle cost of the system. Since the MTBF is high, now you don't need to replace a cooler every 1 year or 2 years. For 30,000 hours and more, this give you a lifetime operation of the product.
Right, and it should be designed for 15 years of operation in the field, and you don't want to work with the product or do the maintenance every 1 or 2 years. So this is about the focal plane array, DWIR and cooler. I would like to show you now the electronics of the product, which is also, there are some new things that we introduce in here. So it is composed of 2 boards. You can see this is the side view, this is the side board, and this is the top board. Actually, these 2 are connected together and act as one system. This board on the side is the cooler driver. It drives the power to the cooler connected directly to the cooler electricity. And it is connected here to this motherboard of the Sparrow. So in this motherboard, we have an FPGA, which does the control both of the cooler and of the FPA. So the total product is controlled from one central point. So as a customer, you don't need anymore to work with 2 separate electronics that are working in parallel. Here it's all digital, so you can command everything through one channel and everything is integrated.
Yeah, I think this is a very important point that you say, actually coming back to the customer experience, to the interfaces. If previously you had a different electronics to control the cooler, different electronics to control the FPA, you needed additional electronics for doing the electronics conversion from analog to digital and then to do all the image processing. Actually, we are combining everything in one electronic. This is unique approach and simpler the integration efforts of our customers.
Exactly, and not only that, we also included some layers of software inside this FPGA, supporting the output. So we discussed the inputs, but let's talk about the output. So the output of the focal plane array itself is already digital. Now, the output from the video board to the customer is standard. It's a camera link, and it's digital. But if in standard detector you have raw data coming out, here you have layers of software that you can use as a user. And these layers of software is completely configurable to do several things. First of all, they can give you a corrected image with non-uniformity correction and bad pixel replacement. But this is not enough for imaging systems. Imaging system would like to have the perfect image with dynamic range compression, noise cancellation, all of these fine features that give you an image that you can put on a screen. Everything is included in this Sparrow electronics, and as a customer, you can play with that, you can configure that, you can turn it on, turn it off, fully configurable, and the idea is once you get it, you power it up, and immediately you can get a picture that you can put on a screen, and then optimize according to your system.
So let me ask you a question. If I'm a customer, and I'm already using my image processing capabilities with my own electronics, I can use it and continue to use it, and I don't have to use your integrated image processing here. Exactly.
You don't need to worry about that. You don't have to use SCD processing. You can configure the detector to raw digital data, as in every product, and work your own processing. You can even start with ours just for a demo and then move to yours.
This is very smart.
It's very flexible and customer friendly in that sense.
So this is important, the flexibility which enables the customer to select the level of integration he would like. He can work with the raw data, he can work with the raw corrected data,
right,
or with the full image processing data, depend on what you want. So actually, you can start and do fast integration, do demo to your customers with our image processing. You don't need to invest a lot.
If it saves time and money for you.
And then once you have your leading customer, then you can switch.
Right.
This is very smart. The frame of the Sparrow is also very uniquely designed.
Yeah.
Can you address this?
Yeah, Kobe is referring to the mechanical frame, this black part that you can see here, which serve to hold the pieces of the Sparrow together. So it's also something which saves you some work at the system level because everything is arranged perfectly here. And on the rear side of the product, you have the mounting surface, which is flat. There are some mounting holes and accurate positioning holes for you to align the product with the optics. And this is the rear part. Also, you can see that there are some of the frame is getting into the product, and the purpose of this is to take the heat out of the cooler and take it to the rear part. So the mounting surface is also the heat removal surface from the product, and everything is designed to remove the heat from the parts to the surface where you mount it. Now let's look at the other side, or then on the front end of the product. Here you can see that there are also some features on the front side of the product, and these features are designed here in order to allow you the mounting of some optics. You can actually put the optics on top of the Sparrow here in front.
Wow. I want maybe to say that actually this is, when we say a camera core and MWIR camera core, this is a full camera core. This is actually the optical bench. You have the video processing. You just need to connect your optics and you are ready to work with your end user and to find the correct way to integrate it into your application. I want to tell you that we have partners which already have off-the-shelf optics for this detector, different kind of optics, different kind of zoom for different kind of application. So don't hesitate. If you need support with optics for this device, we can connect you with the optic guys which can provide you the optics for this detector.
Right. I would like to wrap up the technical presentation and give you the key features in terms of the specification. So it's a VGA 10 micron pitch with XBN technology built inside, 60 by 60 by 40. This is the dimension, less than 300 grams, the weight, less than 4 watts. That's the power consumption of the product. Now look at on the cooldown time or the image ready, it's less than 3 minutes. The standard is f3.6. Frame rate can be variable between 30 Hz to 180 Hz, either processed in video frame rates or raw data running at 180 Hz. Standard market operability above 99.5%, great uniformity, good sensitivity, and the MTBF is more than 30,000 operating hours.
So maybe to summarize this, too, we talked in the beginning about the superb performances of the 15 micron pitch. Can you say that we achieved it in the Sparrow?
Yes, we get this feedback from our customers that the image is just perfect. The same image experience as you have from all SCD products, either VGA, legacy Pelican D, the same image quality, while having this fabulous low size, weight, and power capabilities of the product. So, yes.
And I think that when we say that we have feedback from our customers, it is amazing. I want to share with you that in the last 12 months, or maybe 15 months, we gain more than 20 new customers using the Sparrow, doing design in, and not even designing. We are already started to deliver manufacturing unit to customer, which are delivering manufacturing solution to their customer based on the Sparrow. The amazing thing, this is with a very wide applications that we didn't expect it to be in a very short time like that. We have customer globally, starting from the east to the west, worldwide, in Israel, in Europe, in the US, and in the Far East. They are using it for airborne payloads. They are using it for tactical 5-inch, 6-inch, and 8-inch payload, actually providing superb 15-inch payload with this small detector. We have customers which are using it for handheld application. Superb handheld application, cutting the weight of their handheld by half based on that, because the optics is smaller, the detector is smaller. They are able to integrate more channels in their solution because we reduce the size. So now they are integrating SWIR. We'll talk about SWIR in our webinar and doing more. I want to ask you something. What is the status of the product?
So the status of the product, this product is fully qualified as of the end of last year. But not only that, as you mentioned, people already integrate that in several different systems. And some of the system already done qualification at system level. So actually the product is qualified on two levels, also at the detector level and on the full product level. So this shows you the maturity of the product. Another element of the maturity of the product is the ready to production, right? We built a product to be used in mass production. And in order to be ready in mass production, we take it into two phases. One is the low rate initial phase, LRIP. And this was done in 2020. So we have produced in 2020 more than 200 units as part of the low rate production and optimize the production line. It is a struggle at the beginning because everything is new in this product. Everything is unique. It's not the same as before. And you have to work with the production until you reach something which is smooth. And we are now at this point where everything is ready for the mass production. And the number are 1,000 units per year. So
1,000 and more.
And more.
Yeah. So I want to say maybe to complete what you have said regarding the Sparrow and the product. The Sparrow is a technology. It's a technology which enable us to bridge the gap for our customers and for the operational need. But this is also a business model. This is also a business model where actually we are changing the way we are working. We are enabling you to do fast time to market development, reduce your effort and come to your end user fast with a system solution. Normally, the lead time for cool detector will be between 4 to 6 or even 8 months, depend on the product. This time we are reducing the lead time to less than 2 months. To less than 2 months. This is available immediately for your use. Just contact us and we are able to deliver in less than 2 months this product. The economy of scale is a critical issue in this detector. The economy of scale enable us to enable all of our customers to enjoy the cost effectiveness of these products. This is a new way we are marketing. This is a new way we are selling. Tuvi, why Sparrow?
So people ask me this question from time to time, why Sparrow? So Sparrow, you know that all our detectors are named after birds. So we selected the name Sparrow because the sparrow bird is a very small bird, so that's trivial. But it's also widely spread. It's very common. You can see it everywhere. This is one element of the name that comes and react with this product. Another thing in the Sparrow that not everybody knows is that Sparrow in Hebrew is dror, and dror, the meaning of dror in Hebrew is freedom, is liberty. And here you have the connection to the first slide where we showed you the sparrow and the Statue of Liberty. And when we say liberty and freedom, what do we mean? Actually, the idea was that people think about cool detector as something which is very big, a little bit complex to use, maybe too expensive. And we wanted to free our users from these limitations so they can innovate and imagine new system to do around the Sparrow. So freedom is deeply embedded in the idea and concept of the Sparrow.
So we can say that actually the Sparrow provide our customer with the power and freedom to innovate. And I'm sure that they will take it to the next stage. Tuvi, I want to ask you something. You know, the Sparrow is already here. And we want to keep you busy.
Thank you.
What is the next step?
Okay, so we don't stop with the Sparrow. We always innovative and looking for the next product, next technology that we can introduce. And the next step is 5-micron pitch technology. So from 10 micron, we're going to 5 micron.
Wow. A
big step. It's a huge leap in terms of the technology. It's a total different technology, different readout technology, different fab processes, completely new. And this is the challenge we are facing. And actually, we have able to produce the first prototype of a 5-micron detector in SCD. And this is part of the next step when you go along the Sparrow roadmap. And imagine what you can do with a 5-micron technology and the Sparrow concept if you put them together.
Well, I don't want you to imagine. I really want you to see. So actually, what happened is that in our next seminar, we'll talk about the 5-micron pitch. Actually, the future is here. 5-micron pitch is not really in the far future. We are already having the first product in 5-micron pitch XBN technology. And in 1 month from now, we'll have additional seminar or additional webinar, which will talk about the 5-micron pitch and about the next generation of Sparrow-like product. I would like to thank you all, to thank you for joining this webinar. Thank you for sharing the time with us and listening to us. I would like to thank Marina, our Marcom coordinator, which allowed us and arranged this webinar. I would like to see you soon, not only on webinar, I would like to see you face to face. Unfortunately, the COVID-19 is still with us, still keeping us in-house domestically, but with this webinar platform, we can share with you all the capabilities. Both, by the way, Tuvi and myself, we are both after our second vaccine, so we are okay that we are so close together. See you soon. Keep health. Thank you very much.
Thank you.